Some developers treat Hibernate as heaven sent. Others blame it for nasty performance problems. Should you ditch Hibernate or double down? Let's find out. We will explore where Hibernate shines, where plain JDBC or Juke are better, and how to take the best of both worlds in one project. Hibernate is an object relational mapping framework. In other words, it follows the ORM approach. This approach means that instead of manually writing SQL queries or mapping database rows to application fields, you just manipulate objects, and the ORM tool usually translates that into database operations. So, Hibernate acts as a translator between Java objects and database tables and relations. It handles the SQL and mapping for you. Hibernate sits on top of the Java Database Connectivity API, or JDBC for short. It provides data access from the Java programming language. So, Hibernate calls JDBC under the hood. But as Hibernate is an ORM tool, it implements the Java Persistence API, or JPA. JPA is a standard specification. Basically, it's a set of interfaces and annotations that define how an ORM tool must work. Hibernate provides an implementation of JPA-defined APIs such as Entity Manager Factory, Entity Manager interfaces, mapping annotations, and so on. Plus, it includes some additional features. That is, a native Hibernate API that includes, among others, the Session Factory that extends the Entity Manager Factory, and Session, which extends the Entity Manager. Plus, it provides some extra mapping annotations that can be used with JPA APIs or a native API. Also, it supports multiple SQL dialects, which are classes that translate Hibernate query language into the native SQL dialect of the target database. Hibernate supports PostgreSQL dialect, Oracle dialect, MySQL dialect, and many others. You write your domain models, and then you use Hibernate APIs or Hibernate Query Language or JPQL to perform the CRUD operations. Hibernate generates SQL, or we can write native queries, and talks to the database using JDBC under the hood. It uses JDBC to open connections, execute the generated SQL, and fetch the results. Hibernate can accelerate development and boost developer productivity. There is no need to bury yourself in writing absolutely all SQL queries. Most, like 95% queries of Hibernate work just fine, and the others you can tune manually. Plus, there is no need to waste time on manual mapping of standard relations such as one-to-many, many-to-many, and so on. It is a piece of cake for Hibernate. You can work with the different relational databases with minimal changes. Also, Hibernate is deeply integrated into major frameworks such as Spring, Quarkus, or Micronaut. Plus, complex tasks such as caching, auditing, validating are already solved in Hibernate. For example, let's take caching. Hibernate caching feature stores frequently accessed data in memory, reducing the number of database round trips. The application looks into the cache before hitting the database, which improves performance. Hibernate provides two levels of caching: first-level cache and second-level cache. The first-level cache stores entities that are frequently used during a single Hibernate session. This cache is enabled by default. The second-level cache stores data frequently used across different sessions. It reduces the number of database queries, but it must be enabled explicitly. So what are good use cases for Hibernate? For instance, when you implement the domain-driven design with domain models that are based on pretty standard relations, such as many-to-one, one-to-many, many-to-many, and so on. Or you need to do specific operations such as locking, as Lucas Eder pointed out in his article on comparing Hibernate to Juke. Also, your project may need to run on different databases, and you don't want to litter your codebase with database-specific SQL. And you're ready to deal with issues related to badly implemented lazy loading, cache, equals hashCode plus n+1 issues in exchange for less code. But there are some situations when you might want to say goodbye to Hibernate. The tool has several drawbacks. First of all, it is an abstraction. And it is a so-called leaky abstraction. It means that it might lead to performance issues when everything was working fine, and then one day you hit n+1 issue that has been sitting there in your code all that time because of some badly written logic. A little side note here. So the n+1 issue arises when you have an initial query that fetches a number of records from the database, and then another query is executed on each record to fetch data on related rows. For instance, we have suppliers and products. We fetch all suppliers and then iterate over them to fetch all their products to retrieve the name of each product. This logic may result in a new query for each supplier. And so each query has to be sent to the database performs it, and sends results to the application. And that may take a lot of time and resources. The more queries, the more time and resources. Another drawback of Hibernate comes from its power, ironically. Hibernate is a very complex tool with some powerful features, but the misuse of these features, like cache or lazy loading, may lead to performance issues. Also, writing equals, hashCode, and two-string methods with Hibernate is not trivial. You need to ensure the consistency of equals and hashCode and make sure that your two-string method doesn't trigger lazy loading on all fields. In the description, I have attached the links to two great articles by Vlad Michalcia and Thorben Jansen, where they explore how to better implement these methods with Hibernate. So, what are the use cases that are better suited for SQL-first approach? Firstly, you may have complex reading queries that implement window functions, complex joins, DB-specific features, and so on. Hibernate struggles with that. Also, your code might be more data-oriented than object-oriented, and that is also a call for plain SQL. Thirdly, you can use complex data models. Hibernate may struggle with some things, for example, referencing a part of a composite key. Another example, it is impossible to map JSON to an actual data structure in Hibernate. On the screen you can see the example of a query that Hibernate might choke on. Here we have the window function. It looks at all rows in the result set and then sorts them by the expression given in order by. Then it assigns a rank number based on the order. We also have the anti-join. It's like a join, but it only keeps rows that do not have a match in some other set. So in this case, we include suppliers, but we only count non-recalled products. And as a result, we rank suppliers by revenue from products which weren't recalled. Okay, so imagine that we have, again, suppliers and products. And with this query, we want to generate a report on the suppliers. We want to count their revenue based on the products that weren't recalled. And then we want to rank them according to their revenue. And then we also want to calculate the average price for each supplier. The query that I showed you is better written with the plain SQL. And maybe you shouldn't trust Hibernate in generating such a query for you. But actually, the question using ORM or SQL may have a more surprising answer than you think, because actually you can use both of them in one project. You see, Hibernate and JPA were designed to work together with handwritten SQL, not to replace it completely. And even the creator of Hibernate says that even if you use Hibernate, you don't have to use it everywhere. So ORM and JDBC solve different problems. But it also means that you can use both of them in one code base. There's a great book by Vlad Michalcia where he describes how to do that. Essentially, you can use Hibernate for CRUD operations and plain SQL like JDBC or Juke for cases where ORM struggles. I hope you found this video useful. Drop me a comment whether you are totally satisfied with Hibernate or you would like to say goodbye to it. And as usual, don't forget to like, subscribe, and until next time!